So keep in mind we just finished 6.3 on complex fractions. That's not going to be on your tests. That was just a little background. It was only 10 minutes long and gave you a little preview, but now we're moving into rational equations. These would be equations that have fractions. Back in chapter 1, which in 105 you folks don't cover, we went over fractions and equations, so this will be a little review. So these are rational equations, equations that have fractions in them. And you may recall that restrictions may exist. If a value of x comes out as a solution, let's say x equals 2 and x equals 3. If the 2 makes one of the denominators a 0, then that is excluded because that would be undefined. So that's what they're talking about here. Otherwise, we want to use all our techniques that we have in our little kit to solve equations. Okay, let's work this one first. Now, a good technique would be to copy your equation down, which is what I've done, so we don't destroy the original. If you're using this, which makes it a little easier, but you want to have what your original equation looked like so you can check it. What we want to do now is multiply every term in this equation by the least common denominator that will get rid of all of these denominators here. And it happens to be 20. So I'm going to multiply every term by 20. Now notice what happens. The 5 cancels, and we end up with a 4. The 2 cancels, we end up with a 10. The 4 cancels, we end up with a 5. Notice now all my denominators are 1. Okay, so now we multiply through, and this gives us 4x equals 10x minus 5. And you should check your work. We want our x's to be positive, so I'm going to transpose this. This gives me a 6x there. Transpose that. This gives me a positive 5 there. Divide both sides by 6. I get x equals 5, 6. And it would be sort of daunting if I had to deal with all these fractions. Now, this equation is not the same as this one, but it's equivalent because we made it bigger, every part of it bigger, by multiplying it by the least common denominator. And we use that so that we could get rid of all these fractions in the bottom. And they're doing it pretty much the way we did. Notice they ended up with negative x, but by dividing both sides by a negative, they got the same answer. Okay. All right, now let's do this one. So I've rewritten it so I can see my original. And as I look, what will be my common denominator? Well, 15x. Now, 3x goes into there once, 3x goes into there 5 times. X cancels with the x, that gives me a 15. Here the 15 cancels with the 15. So I now get 5x. No 5x, just plain 5. I'm thinking ahead already here. So 5 times 1 is 5, plus 15 times 1 is 15. X times 4 is 4x. So again, I'm looking for my common denominator, which was 15x. Multiply every term by 15x. Cancel out, so all of my denominators now are 1. Multiply through, and I now get 20 equals 4x. Divide both sides by 4, 20 equals 5. Now, in the previous one, we didn't have letters in the denominator, but here we do. Does 5 make any of my denominators a 0? And the answer is no. So that's the qualifier they're asking us to watch out for. And pretty much what we got, and there it is. Okay. And they're showing us what it would look like on a graph. Okay, next one. Okay, we've rewritten this, and some of our old friends are coming back here. We see this is the difference of perfect squares, and these, interestingly, are their conjugates. So our common denominator will be this. Now, another way to do this sometimes is to do it like this. X minus 1, x plus 1, and we're going to multiply it like so. Another way. I like putting it by each one, but we can also do it this way. Now here, this one cancels out, and we're left with 2 times x plus 1 minus, and the 5 is there, minus 5. Now this one's going to cancel out, and we're left here with x minus 1. And now all of this cancels out, so we're just left with a 4. So all this cancels out here. So this is going to be 2x plus 2 minus 5x plus 5 equals 4. We're going to group like terms, and to let us move a little quicker, we get this line. I transpose my positive 7 to the other side. It gives us a negative 3 there. Negative 7 and 4. Divide both sides by a negative 3 here. I get x equals 1. And you might say, oh, I got x equals 1. But now, watch this. If we take this 1 here and put it in this equation, 1 minus 1 is what? 0. It's made this denominator a 0. So this cannot be an answer. Remember, we said that there were some that would not be able to be answers if they make the denominator a 0. This is a restriction. So for this equation, there is no solution. All right, let's check it out here. And that's what they did. They used a little different technique. They got that. They got all of that. They got that, and they got that. Okay? Now, that's going to be one of your choices, possibly. And if you put that into MATLAB, they're going to count it wrong, even though you did all of this correctly. So it says because a 1 has to be rejected because it's making this denominator a 0, this equation has no solution. All right, how about this one? Okay, there it is. Notice I factored this. This is the difference of perfect squares factors into its conjugate. So we're going to multiply everything here by y plus 3, y minus 3. So here it all cancels out. So we end up with a 5. Here the y plus 3 cancels. So we have to multiply this by the y minus 3. Here this cancels. So y plus 3. So that's a lot easier. 5 equals 3y. And to save a little time, we distribute this, collect like terms. This gives me a y. This gives me a negative 15. Transpose that, I get y equals 20. Now notice, y is 20 does not make any of my denominators a 0, so that's a good solution. And that's what we got. We multiplied through, and we got that, and there it is, y equals 20. Okay. All right, now we're moving into function notation. Here we're saying that f of a is equal to 7. So this part right here equals 7. So that's what this is going to be as we rewrite. And we can actually use their material. I'll just review it with you. So this is going to be a 7 here. That's what they're saying. So we just set it up like so. So now, how do we do it? So we're going to multiply to get rid of our fraction here, a, every term by a. So this then becomes a squared plus, here the a's cancel out, 12, and this becomes 7a. But we have a quadratic equation. How do we solve quadratic equations? By putting it in standard form and factoring. So a squared minus, transpose that, 7a plus 12 equals 0. Now we factor a, 4, 3, both minus. So here A will equal 3. Here A will equal 4. So our values that will satisfy this will be either a 3 or a 4. And neither of them make our denominator a 0, so that's good. And that's what we did. Factored it, and those are our answers. And if we check it, they both check. And that's what it looks like on a graphing calculator. Okay, you're going to do some practice again in the section on additional exercises. I work through a lot more problems, and hopefully they're going to be helpful for you. Thanks, and hope you're doing good work.